And this is Unit 5 of our chemistry break on atoms and compounds. And in this section, we will learn about balancing chemical equations. So far, we've talked about how atoms are formed. We've talked about how we can arrange the atom and how atoms can go ahead and be bonded to different atoms via ionic or covalent bonding. Now, we're going to talk about what happens when these different atoms come together. And when these different atoms come together, we've seen that the atoms come together, they can share electrons, so they might become ions, and as they become ions, they will have these charges that form part of a chemical reaction. And that chemical reaction is the combination of these atoms or the elements. And as they combine, there can be breaking of bonds, there may be building up of new bonds, and there may be a combination of both. So the chemical reaction is very complex, and of course, it always goes towards something that's most energetically favorable in terms of the compounds that are being formed. So, for example, a typical chemical reaction that most of us may be familiar with would be carbon dioxide and water coming together using energy from the sun to produce plant materials and giving off oxygen. And, if we study this in sort of a picture form, you would see that this is the whole process of photosynthesis, where the plant takes in carbon dioxide, water from the soil, uses that energy to produce these sugars, and of course, give off oxygen. The sugars are the fruits in forms of fruits or leaves or whatever the plant may need. Of course, humans benefit from that as well. So that's a very familiar chemical reaction, and it's very complex in terms of the chemicals and the elements and atoms that are involved in that. Now, when we come to balancing equations, we are going to take these chemical reaction, like we saw earlier for photosynthesis, and we're going to describe this reaction in terms of the proportion of the reactants that we need, and also balance it in terms of determining the proportion of the products that we get from this. So whenever we have a chemical reaction, we have the things that's coming together, the atoms, the elements, the bonding, whatever that's happening, and that gives us the end result, and we call that the product. So carbon plus oxygen gives carbon dioxide. It's a chemical reaction written in word form, and we can have that written in equation form. So this is a chemical equation. Now let's look at how we go ahead describing these chemical equations. When we're using a chemical equation, we're trying to balance the chemical equation, we have to start by counting atoms. So if, for example, with our carbon and oxygen, we have just C by itself, it means we just have one atom of carbon. O is the element symbol for oxygen. O sitting by itself means we only have one atom of oxygen. O with the subscript 2 means that we have one molecule of oxygen, which consists of two atoms. C and O coming together means we have one molecule of carbon dioxide. CO2 is one molecule of carbon monoxide. CO2 is one molecule of carbon dioxide. In this molecule of carbon monoxide, we have one carbon atom, one oxygen atom. And that's a whole different molecule from the carbon dioxide, which is one molecule of, one atom of carbon and two atoms of oxygen. Carbon monoxide, harmful to humans. Carbon dioxide, well, that we breathe in that from the air. It's not very harmful to our bodies. Of course, we can't survive on carbon dioxide alone. 3 CO2 means we have 3 molecules of carbon dioxide. And in that, each molecule of carbon dioxide has 1 carbon and 2 oxygen. So we have that 3 times. All right, so when we start counting it, let's go back to our product here. And so we have, in this case, 2 in front of the C. That means we have 2 atoms of carbon. We also have a 2 here with our diatomic oxygen. And so we have 2 carbons and 2 oxygen when we're adding just the atoms together. And if we have 2 CO here, you see we have the carbon monoxide compound. It also has 2 carbons and 2 oxygen. And so we will say that this chemical reaction is balanced because the number of atoms in the reactant is equal to the number of reactants in the product. Sorry, the number of products that we get. Number of atoms in the reactants is equal to the number of atoms in the product. So let us look at another example here where we can apply these rules. So again, we're going to start with an unbalanced equation. In this one, we have CH4 plus O2 giving the product CO2 plus H2O. Now, some of these you might be familiar with. For example, CO2 is 1 molecule of carbon dioxide, H2O, 1 molecule of water. CH4 you might not be very familiar with, but it's the chemical symbol for methane or methane. So the next thing we do once we have our unbalanced equation is we count the number of atoms of each kind in the reactants and in the product. So it's going to look something like this. We make a list of reactants, we make a list of products. We have 1 carbon here because we have just C by itself. H4 means we have 4 atoms of hydrogen. O2 means we have 2 atoms of oxygen. Now let's go to our products. We have C, which is 1 carbon atom, so that's 1C. O2 means we have 2 atoms of oxygen here, but we also have an oxygen on this side next to the H2O. So when we add up the 2 and 1, we get 3 atoms of oxygen. And then we have 2 atoms, H2 atoms of hydrogen. So when we compare them, sure, our carbon seems to be balanced, but we have 4 hydrogen atoms compared to 2 hydrogen atoms in the product, 2 oxygen atoms in the reactant, and 3 oxygen atoms in the product. So we see that it's, in this case, it's an unbalanced equation because when we add the atoms in the reactants and we add the atoms in the product, we see that they're not the same because the number of the same type of atoms must be the same. We should have 4 hydrogen atoms. We should have 2 oxygen atoms on this side for it to be balanced. So now we're going to put coefficients. So when we start balancing equations, we cannot change the things that are written in subscript. We can only add coefficients, that's big numbers, in front of the molecule. So because if we add anything in the subscript, what we do there is we're changing the chemical formula, and we can't do that to a molecule. So the coefficients must be placed in front and not in the bond formula, because that's changing the compound itself. And you have to compare the number of atoms to determine the coefficients to use. So let's go here and we see CH4, O2, our CO2. And now if we put a big 2 in front of our H2O, now we have 4 atoms of hydrogen. All right, so that 2 here, so 2 multiplied by the 2 gives us that 4 atoms of hydrogen. So in this case, now we have our 1 carbon in the reactant and 1 carbon in the product, 4 hydrogen atoms in the reactant, and here we have 4 hydrogen atoms in the product, 2 hydrogen atoms in the reactant, and now we have 2 oxygen atoms in the reactant, and here we have 2 oxygen atoms from our carbon dioxide, plus the 2 multiplied by the oxygen atoms here, so it's O2 plus 2O, so that's 2 plus 2, so we have 4 oxygen atoms. So while our carbon and our hydrogen seem to be balanced, we're still unbalanced or imbalanced because we don't have the exact number of oxygen atoms in both the reactant and the product. So then what we can do is look at this oxygen atom and try to think of a coefficient that we can go ahead and multiply that by so that we can also make the numbers equal. So we can add our coefficient in front of numbers in the reactant, or we can add them in front of numbers in the product, right? So here we have it in the product, we can do it in front of the reactant. Whatever it is, we're not changing the subscript number. We're not changing the number in the formula. So we have 4 oxygen and 2 on the reactant side, product side, and only 2 on the reactant side. So if we look at this, 2, and we multiply that by 2, we can get 4 on this side, and then we have 4 on that side, and it'll be balanced. And so here we have a balanced equation with 1 carbon on each side, 4 hydrogen atoms on each side, and 4 oxygen atoms on each side. And that's how you use the rule of balancing equation to help us get those chemical reactions balanced, so we can see the proportion of the reactants that we use, as well as the proportion of the products that we get from that reaction. All right, and that brings us to the end of this chemistry break that we had. I would suggest, you look up the different sections if you're interested in reading up any more on these. And thank you for watching.